Hi, welcome to A Math Lab. Today I'll be going over implicit differentiation. Okay, sorry my graphics are kind of crummy. I'm not very graphic savvy, so let's get to what I am good at. Let's do a little implicit differentiation here. Let's say you have y squared minus 2y is equal to x. Okay, well if I take the derivative of, I'm sure you remember this, if we just took, let's say, the derivative of x squared minus x is equal to x, well then this would be explicitly taking the derivative of this function. If I took the derivative of this, it would be 2x minus 1 is equal to 1, and then we can just solve for x, right? So if I brought over the 1, so if I added 1 to this side and 1 to this side, we have 2x is equal to 2. And then if I divide by 2, x is equal to 1. So that's explicitly taking the derivative, right? Okay. Implicit differentiation is a little bit different because we have two terms here, so it's a little more difficult. Well, once you get the hang of it, it's not very much more difficult, but it's a little more to it. Well, if I take the derivative of this function with respect to x, then what I'm going to do here is I'm going to say, let's get a little better graphics going on here. Okay, let's see. If I take the derivative of y squared with respect to x, then I have 2y, and then I've got to tag on dy dx. Okay? And then if I take the derivative of negative 2y, well, we keep the constant, negative 2. Well, this y goes away, doesn't it? Because it's 1. The derivative of a variable is just 1. So, and then we have to tag on dy dx is equal to 1. So notice what I did here. Wherever I was taking the derivative with respect to x of y, then I had to tag on this dy dx. Okay? So let's see. If I want to keep on going, if I want to figure out what the derivative of this function with respect to x is, well then now I have to factor out this dy dx. So dy dx, and really I can factor out a 2 as well, can't I? If I do that, then I'm just left with y minus 1 is equal to 1. Well, I can go further. I can factor out 2 times y minus 1 from this side, and I can do the same on this side. So if I do that, then I have dy dx is equal to 1 over 2y minus 1. So that's my derivative. Okay, so notice what I did is wherever I took the derivative of a y with respect to x, I had to tag on this dy dx. And then once I got that, notice I factored out the dy dx. That way I can move everything else to the other side. It's almost like solving a linear equation at that point. Now you're just solving for this term here, getting everything to the other side, really. Let's look at one just a little more involved, and hopefully this one will take it home for you. And hopefully I won't run out of time. Let's see. Okay, let's say you have x y squared minus x squared plus 4. Excuse my y's, they look like 4s. A lot of people mention that, so I'm just warning you ahead of time. Okay, now if I take the derivative of this with respect to x, okay, what I'm going to do here is I'm going to use the product rule. X times the derivative of this term, which is 2y, but remember we're taking the derivative with respect to x. So dy dx minus, I'm sorry, we're doing the product rule, aren't we? Plus, and then we have y squared times the derivative of x, which is just 1, minus the derivative of x squared, which is just 2x, and the derivative of a constant, which is 0. Okay. So notice here we only have 1 dy dx. Not a problem. Let's say, let's go ahead and move some of this stuff over to the other side. So I'm going to rewrite this 2xy dy dx. That's what we're trying to solve for, is equal to, and I'm going to move this over to the other side. If I do that, then I get, this is actually going to be a negative on the other side. Negative y squared, and this is going to be a positive plus 2x. Okay, and I can go further, right? And really what I'm going to do is I'm going to make this side look neater. 2x minus y squared. It's just something I like to do. And then I'm going to divide this side by 2xy, right? Well, if I do that, then we'll have dy dx, and whatever I have to do, if I divide out the 2xy on this side, I have to do that on this side as well, right? 2xy. So that's the derivative of our function, of our equation here, with respect to x. So notice, again, really quick, a quick recap. I used the product rule here, and wherever I took the derivative of y, I basically tagged on just a dy dx here, and you have to do that whenever you're taking the derivative with respect to another variable. Okay, and then once I found that, I solved it just like it was a linear equation. I brought everything else to the other side of the equation to figure out what dy dx is. So if I have an x value and a y value, I can plug it into here, and then I can figure out what the derivative with respect to x. Using implicit differentiation, I can figure out what the rate of change is, basically. Okay, I hope that you found that kind of helpful. I'll probably be doing some more of these as well, so stay tuned, and hope to see you soon. See you back.